Assalamualaikum. Alright, in this video we're going to discuss on the tangent to the curve, where maybe some of you have learned this during your high school, right? So there's actually another meaning of dy over dx here. Okay, so the dy over dx is actually the change of y with respect to the change in x. All right, or sometimes when we talk about the change, so there must be the difference between two values. So if it is the change of y, then it should be y2 minus y1, and if it is the change of x, then this should be x2 minus x1. And if you recall, this is actually all right, so what is this? All right, so this is the equation of the tangent. All right, so m, all right, so we'll write m equal to y2 minus y1 over x2 minus x1, if you recall this during your high school mathematics. But never mind, I'll just do some revision here. So suppose we have this graph, which is the graph of x squared. And what is actually the dy over dx? All right, I'm going to discuss what is actually the meaning of dy over dx. All right, so if we want to see the tangent to the curve, so what is the tangent to the curve? All right, so let's just draw. All right, tangent to the curve is a straight line. So tangent is a straight line. Bear in mind that tangent, all right, bear in mind, tangent is a straight line. All right, I'm going to define this as a straight line. It should be a straight line. A straight line, but a straight line of what? So touching the curve, it must touch the curve. All right, touching the curve. Where? It can be anywhere, but at certain point. All right, at certain point, at the required point, at certain points. So if we want to look at this tangent to the curve at x equal to 1, then we'll focus at x equal to 1. All right. If we want to see at x equal to 2, then we'll go to x equal to 2. In this case, I'm going to look the tangent to the curve at x equal to a. A is any values. It can be 1, 2, or 3. All right. So suppose the value is a. All right. So we're going to draw what do we call a straight line. All right, so it should be a straight line that touches the curve at a point only. So meaning to say that we're going to look at a here. All right, so we'll have to look here. So we'll have to draw a straight line that touches the curve at that point only. Meaning to say, right, if I draw this, meaning to say that I'll just draw. All right, is if you look at this, all right, if you zoom, all right, using the mathematical instruments, should be touching one point only here. All right, one point is touched here. All right, this is the red line is here is called as the tangent to the curve at x equal to a. At that point, it can be anywhere. It can be here. All right, so it can be here. All right, it can be here. It can be anywhere. So it depends on the respective questions. All right, so in this case we want to focus on x equal to a. So if we look at the definition of this y2 minus y1, all right, so suppose we want to draw what do we call this, a triangle here, right? So we're going to connect this to this. So this is actually y2, all right, y2 labeled here, and this is actually, right, suppose I'm going to take this is y1. So I'm sorry, I'm going to call this as y1. So this is the difference, all right, dy, in this case y2 minus y1. All right, so we're going to divide with the, all right, so if you want to draw the triangle, it should be something like this, and this is, it should be x2 and x1. So this is the dx here, where the dx is given by, all right, dx is given at x2 minus x1. So if you find the y2 minus y1, right, which is this length, divided with this length, which is x2 minus x1, if you recall this divided with this is actually the gradient of the tangent, or we can say this is actually the gradient of the curve. All right, so the gradient of the curve, the gradient is actually the gradient of the tangent. All right, so this is actually what dy over dx is. It's actually the gradient of the tangent to the curve at that point. Alright, if you can't see this, alright, never mind. Let's look at equation number 1. So suppose we have dy equal to x squared. Right, so now we want to find, alright, so firstly we're going to focus at x equal to 1. It can be at x equal to 2. Suppose at that, right, suppose this is x equal to 1.5. Alright, so let's take it as an example. So the tangent to the curve should be something like this. It should be a straight line that touches the point only. Alright, depends on the questions. Alright, so if I'm going to focus at x equal to -1, suppose it is here. So x equal -1 is here, so I'm going to draw a straight line that touches that point there. Right, that is the tangent to the curve at x equal to -1. Right, but let's now focus at x equal to 1. So we know that, alright, we know that a tangent is a straight line. So when you talk about the straight line, you recall the formula for straight line, which is given by the y equal to mx plus c. So you have to start, alright, if the question asks you to find the equation to the curve, you should start with the y equal to mx plus c. Why? Because it is a straight line. So we want to find the equation of this line, alright? So now, we know that the m here is actually the gradient of this line. Gradient of this line. How to find the gradient of this line? We have to do the dy over dx, which is given by y2 minus y1 over x2 minus x1. So this is the m, the gradient. So to do that, we'll have to differentiate this. Alright, so to find the value of m, so we are given with y equal to x squared. So to find the m, it should be dy over dx. Right, we differentiate this, we'll get 2x. Alright, but now we're going to focus at x equal to 1. Alright, since x is equal to 1, so the dy over dx, where at x equal to 1. So we're going to substitute the value of x equal to 1 here. So we'll have something like 2 multiplied by 1, which is equal to 2. So we note that the gradient of this straight line is actually 2. And we look at it, it is slope to the slope is tended to the right, so it's positive. So it's, of course it's positive here, and the value is 2. All right, because it's quite steep there. All right, so we already have the value of m, which is given by 2, right? Given here. So 2 of x plus c. All right. So now we know that if x equal to 1 here, so what is the value of y here? All right. So to find this, you'll have to substitute into this function. So when x equal to 1, y should be 1 square. So y should be 1. So the value of y should be 1. So we know that the point here is actually 1, 1. So since the tangent touches the 1, 1, it passes through 1, 1. So we can substitute the value of y with 1 and the value of x with 1. So we'll have something like this. So now we can find the value of c. So 1 equal to 2 plus c. So c should be -1. Alright, so that's the value of c. So now recall that, alright, bear in mind that we want to find the y equal to mx plus c. So the value of c should be written, alright, should be written to this c. Alright, so we'll have to substitute back. Therefore, the equation of the tangent to the curve at x equal to 1 should be 2x minus 1, because the value of c is actually -1. Alright. So that's basically how you do the tangent to the curve equation to the tangent. So remember that the tangent is a straight line, so you'll have to start with the y mx plus c. So to find the value of m, you'll have to differentiate the function. After differentiating it, you'll have to substitute the value of that point, which is in this case that's equal to 1, and I'll substitute at this in this equation where m is actually 2 in this case. So to find the c, you'll have to substitute the value of y and x of the respective points. In this case is 1, 1. All right, so that's how you do it. All right, let's now move to question number 2. Find the equation of the tangent line to the graph of this at x equal to 1. So I'm not going to draw the graph, because in exam you don't have to draw the graph, but if you want to illustrate this, you can draw the graph. Right, so we know that if we want to find the tangent line where we have to find its equation, you should start with the y equal to mx plus c. So the strategy is to find the m first. So how to find the m? So m is given by dy over dx. In this case, f prime x. So write fx first. Fx is given by 3x squared minus x. So we have to differentiate this function, so we'll have f prime x, alright? So please note that we don't have this df over dx, alright? If you write this, and then people will laugh at you, 40 days and 40 nights. Alright, so this should be f prime of x, alright? Differentiating this, we'll get 6x minus 1. Alright, we know that to find the equation of the, to find the gradient, so m is actually given by the dy over dx at that point, in this case at x equals 1. So you'll have to find the f prime of 1. You'll have to substitute the value of x with 1 here, following this, okay? So now, we'll have, alright, so 6 multiplied by 1 minus 1, you'll get 5. Meaning to say that the value of m is actually 5. So you can substitute the value of m with 5 here. So y equal to 5x plus c. Alright, so you have this. So to find the value of c, so in this case, you're not given with the value of y. So you have to find the value of y first. So in this case, y is actually fx, alright? So fx is actually 3x squared minus x. So when x equal to 1, so what is the value of y? So we'll have to substitute the value of x with 1. So 3 multiplied by 1 squared minus 1. So y will get 3 minus 1 will get 2. So we know that the value of x is 1, alright? The value of x is 1 and the value of y is 2. So we'll have to substitute in these two values so that we can find the value of c. So y is actually 2. It's given by 5 multiplied by x is actually 1 plus c. So we'll have 2 equal to 5 plus c. So c should be negative 3. Alright? So finally, you already find the, what do we call that, the equation of the tangent to the curve. So we're given by y equal to m5x, right? So you go back to this 5x, c is now substituted with negative 3. So that's the equation of the tangent. Where, at which point? So you have to mention that it is at x equal to 1, because it can be at any points, but in this case we just want to find at x equal to 1. All right, so that's basically how you do the how you find the equation of the tangent to the curve. Right, in this case, all right, look at the question, read the question carefully. Find the slope of the tangent. Do we have to find the equation? No, we don't have to find the y equal to mx plus c. We don't have to do that. All right, but instead you just have to find the slope. So the slope is given here is actually m. So to find m is actually dy over dx. At which point? In this case, at x equal to 0. So we'll have to substitute with the value of x equal to 0. So firstly, we'll have to find the dy over dx. So we're given with this function. So we'll have to find the dy over dx. In this case, the dy over dx is given by, alright, so to do this, we'll have to use the u over v technical quotient rule. So I'm going to write u is equal to sine of 3x, and v is equal to ln of x plus 1 minus a. Okay, so now we'll have u prime, which is given by differentiating sign. We'll get cos of what? Cos of 3x, but then we'll have to differentiate this 3x, we'll get 3. Right, so I'm gonna write this as 3 cos 3x. Alright, so now I'm gonna differentiate v. So we'll get v prime, alright, given by ln, differentiating ln, we'll get 1 over of that whole thing in the bracket. Alright, so now I'm gonna differentiate the x plus 1, we'll get 1. Minus 8, we'll get 0. So v prime is actually given by 1 over x plus 1. Alright, so now we can find the dy over dx using the formula for u over v, where we start with v u prime minus uv prime over v squared. So note that v and v here, right, if you can't remember the formula. All right, so we're going to substitute into the formula. So v is actually given by that ln of x plus 1 minus 8. All right, you multiply with u prime, so we'll get 3 cos 3x. Okay, so you're gonna minus with the uv prime, sine of 3x, and then you substitute with the v prime is actually given by 1 over x plus 1. Right, so this whole thing, which is divided by that ln of x plus 1 minus 8 square, right, v square. Right, so this is your dy over dx. But to find the slope, you just have to substitute at this point. So you'll have to substitute the value of x with 0 into which function? Into this dy over dx. All right, so we'll have, right, dy over dx with the value of x which is given by 0. Alright, so I'm going to substitute the value of x is 0, so we'll have something like ln, alright, so ln of 1 minus 8. Alright, 3 cos of 0 minus sine of 0. And then we'll have 1 over 0 plus 1. Okay, so this whole thing divided by ln of 0, ln of 1 minus 8 squared. Alright. So we'll have to simplify this. All right, we know that ln of 1 minus 8, ln of 1 is actually 0. All right, so we'll have negative 8 multiplied by 3 cos 0 is 1, so negative 8 multiplied by 3 you get negative 24. Okay, and then you'll have this part is 0 because sine 0 is 0. All right, so that one is 0. So negative 24 divided by ln 1, or negative 8 to the power of 2. So put in the bracket negative 8, and then you take the power of 2 outside the bracket, we'll get 64. So the answer is negative 24 divided by 64. You can write this as simplified fraction, which is given by negative 3 over 8. So that's your final answer, right? So I hope I'm doing this correctly, right? So please check your answer, right? Alright, so let's now move to the question number 4, which is quite different from the previous examples. Alright, in this example, we are given with this equation. Okay, so we'll have to find the dy over dx using implicit differentiation. So sometimes the equation combines the implicit differentiation together with the tangent to the curve. So to do this, we'll have to find the implicit differentiation first, where we're gonna put this, all right, gonna label this as A, this one as B, and this one as C, and also this one as D. All right, so I'm gonna differentiate each term there. So we'll have something like A is given by ln of cos 2y. Okay, so I'm gonna differentiate this, so we'll get something like 1 over cos of 2y, and the differentiating cos of 2y we'll get negative sine of 2y, and then differentiating that 2y we'll get 2 dy over dx. So yeah, if I simplify this, I'll get actually negative 2 tangent sine over cos, right? Tangent of 2y dy over dx. All right, please try to simplify. Right, then I'm gonna differentiate b. All right, so b will have as y equal to, y e to the power of 3x. So we'll have to use the u and v. So u is given by y and v is given by e to the power of 3x. So differentiating u will get dy over dx. Differentiating v will get e to the power of 3x. Differentiating that 3x will get 3. So the 3e to the power of 3x. So to get b prime, so you'll have to cross multiply this, multiply with this, so we'll get 3y e to the power of 3x plus this one multiplied by this one, we'll get e to the power of 3x dy over dx. Right, so next we're gonna differentiate c, where c is given by the function c is actually, what do you call, 5x squared So c prime should be 10x, and d is given by 4. So that is a constant function, so differentiating the constant will get 0. Alright, so I'm going to substitute into the formula where it's given by a plus b minus c equal to d. So we'll get a prime plus b prime minus c prime, we'll get d prime. Alright, so I'm going to substitute with a prime first. So this is a prime, negative 2 tangent of 2y dy over dx. And then we're going to plus with the b prime, is actually this part here. 3y e to the power 3x plus e to the power 3x dy over dx. And then we're going to minus the c prime, which is given by 10x, and which is equal to d prime, which is given by 0. So always remember, when you have the implicit differentiation, we will reach this level. We have to collect all those terms with dy over dx to the left side, but those without the dy over dx should be brought to the right side. So we'll get negative 2 tangent of 2y of dy over dx. We'll have plus e to the power of 3x dy over dx. So we'll have something like, alright, I'm going to bring this negative 10x first, so positive 10x, and I'm going to bring this one, so we'll get something like minus 3y e to the power of 3x, right? So I'll have to factorize the dy over dx, so we'll get something like, negative 2 tangent of 2y plus e to the power of 3x dy over dx. So this is given by this right hand side. So I'm gonna bring the one in the bracket to the right side by the process of division, so I'll get final answer as, so dy over dx is actually given by 10x minus 3y e to the power of 3x, the whole thing divided by e to the power of 3x minus 2 tangent of 2y. Alright, so that's the finding the dy over dx using implicit differentiation. So now what I'm going to do is to find the equation of the tangent line. So highlight the equation of the tangent line. We know that equation of the tangent line is actually the equation of a straight line. So we should start with the y equal to mx plus c, because the tangent is a straight line. So to find the m, we'll have to use the dy over dx, at which point in this case at x equal to 0. Okay, so we already have the dy over dx given by this function. So to find the dy over dx, alright, dy over dx at x equal to 0. So I'm going to substitute the value of x with 0 into this function. So I'll get 10 multiplied by 0 minus, alright, 3y e to the power of 0. Y is actually given by, y is actually given by this, alright, pi over 2. So 3 pi over 2 multiplied by e to the power of 0. Okay, at the denominator we'll have e to the power of 0 minus e to the power of 0 minus 2 tangent of 2 multiplied by y. So 2 multiplied by y here is actually given by y is this pi over 2. So 2 multiplied by that will get pi. So tangent pi. Alright, so this part will get 0. This part will get 1. This part will get, this part will get 1. Alright, so at the numerator, I'm gonna have negative 3 pi over 2. At the numerator, I'll have something like y minus, so 2 tangent pi. So tangent pi, alright, so make sure that your calculator is in radians. So tangent pi will be, so your tangent pi will be 0, right? So this part will be 0. Okay, so my final answer should be negative 3 pi over 2. This is the gradient of the curve at x equal to 0. Alright, so we already have the value of m there. So I'm going to substitute the value of m with this value, which is given by negative 3 pi over 2. So we'll have x plus c. We have the formula y equal to mx plus c, where m is given by this value. Alright, so now we're going to find the value of c. So to find the value of c, we'll have to substitute the value of 0 pi over 2. We have that xy, which is given by 0 pi over 2, where the value of x is 0 and the value of y is pi over 2. So the value of pi is, the value of y is pi over 2, and the value of what we call x is 0 plus c. So in this case, we got c equal to pi over 2. So what our final answer will be y equal to, I'm going to return to this equation, negative 3 pi over 2 of x plus c. So that c will be this value, where it is actually pi over 2. All right, so this is the what we call the gradient of the tangent line for this function at this given point. Right, so sometimes the question can give you in form of this equation and ask us to find the dy over dx using implicit differentiation. From the implicit differentiation, we can actually get the value of the gradient to the curve, all right, or gradient of the tangent line to the curve at certain given points. All right, so basically this is what dy over dx. So please take note that dy over dx is actually the gradient of the tangent line to the curve, at which point it can be at x equal to a, it can be at x equal to 0, it can be at x equal to -1, it can be at x equal to -1 over 2, it can be anywhere. It depends on the question. So we'll have to substitute the value of that point to get the value of the gradient. And we note that the tangent line is a straight line that touches the curve at the given point, but it touches at only one point, meaning to say that if you have the curve, so if the tangent line at this point, it only touches that point, all right, it doesn't touch any other points. If you want to find the tangent here, so we'll just have to touch the point there, right, touch the curve. All right, so because it is a straight line, so we can use the formula of y equal to mx plus c. All right, so that's it for this video. Thank you for watching.